In this video, we are going to practice graphing and evaluating piecewise functions. Now, I have taught two different methods for graphing a piecewise function. One involves a calculator, and the other one involves just using our knowledge of lines and slopes. So for this first problem, I'm going to do the calculator method, and then I'll switch back to y equals mx plus b. All right, so let's graph this one piece at a time. So I will look at this top piece as the equation y equals x plus 2. So I could put that right in my TI-30XS multiview, hit the table button, and I could put x plus 2. Now, where do I want to start? Well, the domain restriction tells me what the end point of this piece is going to be. So the end point is going to be at -2. So that's where I want this to start. So I'll type -2. Just hitting enter a few times. So I've got the point -2 comma 0. Okay, now this is going to be an open circle because it doesn't have the or equal to line under it. So -2 comma 0 is right here. So open circle. Now for more points, I will again use my domain restriction. I want x values that are less than -2. So that would be numbers above -2 like -3. All right, this is less than -2. So -3 comma -1, okay, would be a point. Let's keep going. -4, -2. And you can see the pattern. What do you want to bet the next one is -5, -3? Well, surprise, surprise. -5, -3. Okay, so we started at this endpoint and we're moving in this direction. Okay, so that's what the top piece should look like. Now let's do the bottom piece, which again is like y equals 2x plus 1. So back to the calculator, hit the table button. We'll do 2x plus 1. Hit enter. Let's see, we still wanted to start at -2 because of the domain restriction. So -2. Enter, 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 enter. So we have the point -2 comma -3. This will be a closed circle because of the or equal to aspect of it. So -2 comma -3 closed circle. Now for more points, we want to go greater than -2. So greater than would be going down. So like -1, -1 would be on there. Okay, and 0 comma 1 would be right here. Now by now you see the pattern. It's going up 2 over 1, so I could just continue that pattern. Or if I was really clueless, I could just keep scrolling down and see more points like that. But see the point 3 comma 7, for example? Well, okay, that's off my grid, but you get the idea. All right, you can get all the points you want either off the calculator or once you see the pattern, just continue the pattern. And that's it. We have graphed problem number 1 using the calculator. Now let's go ahead and talk about evaluating. Let me sort of do this over again. All right, when you're evaluating, you're going to wind up taking this number and substituting it in for x. But don't do it for both functions. You have to decide which function you're going to use, the top function or the bottom function. Well, -3, is that less than -2 or is it greater than or equal to -2? -3 is less than -2. That tells us that we have to use the top function, which is x plus 2. Okay, so if we do x plus 2, then that becomes -3 plus 2, which is -1. So that answer is -1. Now how about -2? Is that going to be the top function or the bottom function? It's going to be the bottom function because negative 2 equals negative 2. So that equal tells us to use the bottom function, 2x plus 1. So I'm thinking 2x plus 1, that's 2 times negative 2 plus 1. That's negative 4 plus 1, that's 3. Now, what about f of 1? Well, 1 is greater than negative 2, so again we'll use the bottom function. So 2x plus 1 becomes 2 times 1 plus 1, which is just 2 plus 1, which again is 3. So that's how we would evaluate. Okay, now let's move on to problem number 2. But this time we are not going to use the calculator. All right, this time we're just going to do it by hand. So this top equation is y equals 2. So please understand that y equals 2 is a horizontal line at 2, like this. All right, this is what the line y equals 2 would look like. But we're not going to graph that entire line. We have a domain restriction. We're only going to graph the part where the x values are less than negative 1. So we're going to put an open circle at negative 1, and less than would be going to the left. Okay, so this is what that top piece would look like. All right, now let's do the bottom piece. So let's see, y equals 3x minus 2. Now if I were going to graph the entire line, maybe I could use my highlighter again. If I were going to graph the entire line, I would start at negative 2, and then I would go up 3 over 1 because of the slope. So up 3 over 1 would look like this. And I could repeat the pattern going to the left by going down 3, back 1. So these yellow dots are sort of showing you where this function y equals 3x minus 2 would sit. But again, I don't want the entire function. I just want, hold on, I was going to use pink, red, whatever you want to call it. I just want the part of the function where the x values are greater than or equal to negative 1. So which one of these yellow dots is sitting at an x value of negative 1? That would be this one, okay, because it's a 1 to the left here. So, or equal to, so this should be a closed circle. All right, now looking at my slope, like I said, this is going to be up 3 over 1. So up 3 over 1, up 3 over 1, up 3 over 1. Okay, so that's why this graph is going to be going like this. All right, so that's what that would look like. We graphed it. Okay, now time to evaluate. Negative 2, are we going to use the top function or the bottom function? Let's see, negative 2 is less than negative 1, so we're going to use the top function. Now this time there's no x to plug into. I just have a constant. That means this is the answer. So the answer is going to simply be 2. Okay, what about 0? 0 is greater than negative 1. So we're going to use the bottom function. All right, so we're doing 3x minus 2. That's 3 times 0 minus 2. That's 0 minus 2. That's negative 2. All right, what about negative 1? Well, negative 1 equals negative 1. So that means we'll use the bottom function again because of the equal to. So again, we're doing 3x minus 2. So that's 3 times negative 1 minus 2. So that's negative 3 minus 2. So that's negative 5. Okay. So that's how you graph and evaluate. See how many problems are on this sheet. All right, you know what? I'm going to go ahead and do these other two problems. Okay, looking at problem number 3. So I've got y equals 2x plus 3. If I graphed this whole function, it would look like this. I would start at 3 on the y-axis, and then I'd go up 2 over 1. So that would be like this, up 2 over 1, and I could follow the pattern to the left by going down 2 left 1, down 2 left 1, down 2 left 1, down 2 left 1, down 2 left 1. So these yellow dots show me where this function sits. But I'm not going to graph the entire line. I'm just going to graph the part where the x values are greater than or equal to 0. Start at 0. Which one of these dots is at 0? It's this one. Open circle or closed circle? Closed circle. Okay? Now, the values that are greater than 0 should be to the right. So this point right here. So this shows the direction in which I'm moving. All right, so this blue is the graph of the top piece. Okay, I'm just going to erase these yellow dots here. And I'm going to start over again with the bottom piece, y equals x plus 4. So, 4. So that means I would start off at 4. Then I'd go up 1 over 1 because the slope is 1. So that would put me here and like here. Now if I follow the pattern to the left, that would be like going down 1, left 1, 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 down 1, left 1. So these yellow dots show where this graph is. But I'm only interested in the part of the graph where the x values are less than 0. Even though it says less than, start at 0. We will show that it's not equal to 0 by making it an open circle. So this yellow dot right here is the one that is at 0. So we will make this an open circle. And then it is less than, so I'm going to go to the left. Okay, so that's going to be these dots over here. All right, that was not a very straight line, but you get the idea. So this is what your graph should look like for number 3. And to evaluate, okay, so I've got g at 0. I'm going to use the top function because 0 equals 0. So that's the 2x plus 3. So that's 2 times 0 plus 3. So that's 0 plus 3, so that's 3. What about 2? 2 is greater than 0, so that's the top function again. So 2x plus 3 again. So that's 2 times 2 plus 3. So that's 4 plus 3, so that's 7. What about negative 2? Negative 2 is less than 0, so this is going to be the bottom function, x plus 4. So that's negative 2 plus 4, so that's 2. So that's how you evaluate here. Hold on, this is bugging me because it looks like a negative sign and it's not. All right, now let's take a look at problem number 4. This will be the last problem for this video. Okay, all these constants are going to be little horizontal lines. So for example, I have y equals 5. All right, y equals 5 is just a horizontal line at 5. Okay, so that would be like this. So here's what y equals 5 would look like. All right, now we don't want the whole line y equals 5. We just want the part where the x values are greater than 7. So we'll put an open circle at 7, and it's because there's no equal to sign, so open circle, and greater than is to the right. Okay, so that's what the top piece should look like. Let's keep going. Now, y equals 3 is a horizontal line at 3 like this. But the domain restriction, 5 is less than x, which is less than or equal to 7. When you see this, you should be thinking between 5 and 7. Open circle, closed circle. So let's see, where's 5 and 7? So here's 5, and here's 7. And here's between 5 and 7. So that's what the second piece should look like. Okay, now let's do y equals 1. Y equals 1 would be a horizontal line at 1 like this. Again, we want the part of this line that is between 3 and 5. So here is 3, and here is 5. And this is the part that's between 3 and 5. Open circle, closed circle. Okay, closed circle on the 5 because or equal to 5. So that's what the third piece should look like. Now the fourth and final piece, y equals -2. Now again, that should be a horizontal line at -2 like this. But we do not want the entire line y equals -2. We want the part where the x values are less than or equal to 3. So here is the point that's at 3, equal to 3. Less than 3 would be to the left. Okay, so that's what this graph would look like. And now let's just evaluate. So in each case, we have to decide which one of these 4 functions we're going to be looking at. Let me zoom out a little bit so that I can fit it all on my screen at once. All right, so this should be pretty simple. Okay, so 6. Is 6 greater than 7? No. Is 6 between 5 and 7? Yes. So that means we're using the second function. And it's just a constant, y equals 3. So that means the answer is automatically 3. Now, what about 3? Now, I see 3 is mentioned in both of these. But 3 equals 3. So I'm going to use the bottom function. So that means the answer will be -2. It's just a constant, so that's automatically the answer. What about 9? 9 is greater than 7. So I'm going to use the top function, and it's just a constant, so the answer is automatically 5. All right, that's going to do it for this video. On the next video, I'm going to show you how to take the graph of a piecewise function and then write the piecewise function that goes with the graph.